This is plan of the lecture. Parallel computing definition, fundamentals of parallel computer architecture, parallel computing software solutions and techniques, difference between parallel computing and cloud computing, parallel difference between parallel processing and parallel computing, difference between sequential and parallel computing. So before we get any further, let's clarify um, how do you think, what is parallel computing? What do you know about it? Okay, who wants to answer?
What was the question?
What is parallel computing? What do you know about parallel computing? Have you ever heard about it? Окей, так. Parallel computing, параллельное вычисление, parallel descriptive, is a type of computing architecture in which several processors simultaneously execute multiple smaller calculations broken down from an overall larger complex problem. Parallel computing, I will repeat again, is a type of computing architecture in which several processors simultaneously execute multiple smaller calculations broken down from an overall larger complex problem. Parallel computing refers to the process of breaking down larger problems into smaller, independent, often similar parts that can be executed simultaneously by multiple processors communicating via shared memory, the results of which are combined upon completion as part of an overall algorithm. The primary goal of parallel computing, цель, да, is to increase available computation power for faster application processing and problem solving. Parallel processing is becoming a dominant way in which very high performance is being achieved in modern supercomputer uh, systems. It's therefore becoming increasingly important that scientists and engineers know how supercomputers achieve parallelism in order to take advantages of the computer's enormous problem-solving capability. A computer solution to a problem must often be expressed so that the parallelism provided by the machine is reflected in the implementation of the program. Otherwise, the system will not perform at even a fraction of its potential speed since the computing resource will not be used efficiently to solve the problem. So, parallel computing um, in the simplest sense, parallel computing is a simultaneous use of multiple computer resources to solve a computational problem. For example, a problem is broken into discrete parts that can be solved concurrently. Each part is further broken down to a series of instructions. Instructions from each part execute simultaneously on different processors. An overall control coordination mechanism is employed. The computational problem should be able to be broken apart into discrete pieces of work that can be solved simultaneously, execute multiple program instructions at any moment in time, be solved in less time with multiple computer sources than with a single compute resource. The compute resource are typically a single computer with multiple processors and the cores. An arbitrary number of such computers connected by a network. So virtually all stand-alone computers today are parallel from a hardware perspective, such as multiple functional units, uh, L1 cache, L2 cache, branch, prefetch, decode, floating point, graphic processing, GPU, integer, and etc. And multiple execution units, cores, and multiple hardware threads. Next is type of parallel computing. Parallel computing structure is typically housed within a single data center where several processors are installed in a server rack. Computation requests are distributed in small chunks by the application server that are then executed simultaneously on each server. There are generally four types of parallel computing available from both proprietary and open source parallel computing vendors, such as bit level parallelism, the first type of parallel computing, instruction level parallelism, task parallelism, and superworld level parallelism. So what is bit level parallelism? Bit level parallelism increases processor word size, which reduces the quantity of instructions the processor must execute in order to perform an operation on variables greater than the length of the word. Instruction level parallelism. The hardware approach works upon dynamic parallelism, in which the processor decides at runtime which instructions to execute in parallel. The software approach works upon static parallelism, in which the compiler decides which instructions to execute in parallel. The third type, task parallelism. Task parallelism is a form of parallelization of computer codes across multiple processors that run several different tasks at the same time on the same data. The last type is super word level parallelism. It's a vectorization technique that can exploit parallelism of inline code. Fundamentals of parallel compute architecture. Parallel compute architecture exists in a wide variety of parallel computers, classified according to the level at which the hardware supports parallelism. Parallel compute architecture and programming techniques work together to effectively utilize these machines. The classes of parallel computer architecture include multi-core computing. Multi-core computing. A multi-core processor is a computer processor integrated circuits with two or more separate processing cores, each of which executes program instructions in parallel. Cores are integrated onto multiple dies in a single chip package or onto a single integrated circuit and may implement architectures such as multi-threading, superscalar, vector, or and etc. Multi-core architectures are categorized as either homogeneous, which includes only identical cores, or heterogeneous, which includes cores that are not identical. The second um, is symmetric multiprocessing. Multiprocessor computer hardware and software architecture in which two or more independent processors are controlled by a single operating system instance that treats all processors equally and is connected to a single shared main memory with full access to all common resources and devices. Each processor has a private cache memory, may be connected using on-chip mesh networks, and can work on any task no matter where the data for that task is located in memory. And the third one is distributed computing. Distributed computing, distributed system components are located on different networked computers that coordinate their actions by communicating via per HTTP, RPC-like connectors and message queues. Significant characteristic of distributed system includes independent failure of components and concurrency of components. Distributed programming is typically categorized as client-server, three-tier, n-tier, or P2P architectures. There is much overlap in distributed and parallel computing, and the terms are sometimes used interchangeably. Massively parallel computing refers to the use of numerous computers or computer processors to simultaneously execute a set of computations in parallel. One approach involves the grouping of several processors in a tightly structured centralized computer cluster. Another approach is grid computing, in which many widely distributed computers work together and communicate via the internet to solve a particular problem. Other parallel computer architectures include specialized parallel computers, cluster computing, grid computing, vector processors, application-specific integrated circuits, and general-purpose computing, graphic processing units, and reconfigurable computing with fields programmable gate arrays. Main memory in a parallel computer structure is either distributed memory or shared memory. Parallel computing software solutions and techniques. Uh, Concurrent programming languages, APIs, libraries, and parallel programming models have been developed to facilitate parallel computing on parallel hardware. Some parallel computing software solutions and techniques include application checkpointing, automatic parallelization, and parallel programming languages. Application checkpointing, a technique that provides fault tolerance or for computing systems by recording all of the application's current variable states, enabling the application to restore and restart from the point in the instance of failure. And checkpointing is a critical technique for highly parallel computing systems in which high performance computing is run across a larger number of processors. The second technique is automatic parallelization. It refers to the conversion of sequential code into multi-threaded code in order to use multiple processors simultaneously in a shared memory multiprocessor machine. Automatic parallelization technique includes parse, analyze, schedule, and code generation. Typical examples of common parallelizing compilers and the tools are Paradigm compiler, Polaris compiler, Rice Fortran decompiler, and the Swift compiler and the Wien Fortran compiler. Uh, the third technique parallel programming languages. Parallel programming languages are typically classified as either distributed memory or shared memory. While distributed memory programming languages use message passing to communicate, shared memory programming languages communicate by manipulating shared memory variables. And difference between parallel computing and cloud computing. Cloud computing is a general term that refers to the delivery of scalable services, such as databases, data storage, networking, servers, and software over the internet on an as-needed, pay-as-you-go basis. Cloud computing services can be public or private, are fully managed by the provider, and facilitates remote access to data, work, and application from any device in any place capable of establishing an internet connection. The three most common service categorizes are in structure as a service, platform as a service, and the software as a service. Cloud computing is a relatively new paradigm in software development that facilitates broader access to parallel computing via vast virtual computed clusters, allowing the average user and small organizations to leverage parallel processing power and storage options typically reserved for larger enterprises. Next is difference between parallel processing and parallel computing. Parallel processing is a method in computing in which separate parts of uh, an overall complex task are broken up and run simultaneously on multiple CPUs, thereby reducing the amount of time for processing. Dividing and assigning each task to a different processor is typically executed by computer scientists with the aid of parallel processing software tools, which will also work to reusable and read the data once each processor has solved its particular equation. This process is accomplished either via a computer network or via a computer with two or more processors. Parallel processing and parallel computing occur in tandem, therefore the terms are often used interchangeably. However, where parallel processing concerns the number of cores and the CPUs running in parallel in the computer. Parallel computing concerns the manner in which software behaves to optimize for that condition. Так, difference between sequential and parallel computing. Sequential computing, also known as serial computation, refers to the use of a single processor to execute a program that is broken down into a sequence of discrete instructions, each execute one after the other with no overlap at any given time. Software has traditionally been programmed sequentially, which provides a simpler approach, but is significantly limited by the speed of processor and its ability to execute each series of instructions. Where uniprocessor machines use sequential data structures for parallel computing environments are concurrent. Measuring performance in sequential programming is far less complex and important than benchmarks in parallel computing, as it typically only involves identifying bottlenecks in the system. Benchmarks in parallel computing can be achieved with benchmarking and performance regression testing frameworks, which employ a variety of measurement methodologies such as statistical treatment and multiple repetitions. The ability to avoid these bottleneck by moving data through the memory hierarchy is especially evident in parallel computing for data science, machine learning parallel computing, and the parallel computing artificial intelligence use cases. Sequential computing is effectively the opposite of parallel computing. While parallel computing may be more complex and come at a greater cost up front, the advantages of being able to solve a problem faster often outweighs the cost of acquiring parallel computing hardware. So, in the conclusion, why use parallel computing? So, the real world is massively parallel. In the natural world, many complex uh, interrelated events are happening at the same time, yet within a temporal sequence. Compared to serial computing, parallel computing is much better suited for modeling, simulating, and understanding complex real-world phenomena. For example, imagine modeling these serials: galaxy formation, planetary movements, weather, and rush hour traffic, and auto assembly, and etc. And main reasons of using parallel computing: save time and more, or save time and or money. In theory, throwing more resources at a task will shorten its time to completion with potential cost savings. Parallel computers can be built from cheap commodity components, solve larger, more complex problems. Many problems are so large and complex that it is impractical or impossible to solve them on a single computer, especially given limited computer memory, and provides concurrency. A single computer resource can only do one thing at a time. Multiple computing resources do many things simultaneously. For example, collaborative networks provide a global venue where people from around the world can meet and conduct work virtually.